Okay, let us move on to next question, and this is a question which has got many parts there, and at a glance you can see the question here. It's all basically all these parts stem from this expression here, z to the power 5 equal to minus 32, and we are required to solve this equation for z, and then we work on them. So let's look at part A first, and this part may look fairly routine to many of you. So we start like this: z to the power 5 is equals to minus 32. Now minus 1 is equal to 6 pi, so I can write that as 32 times 6 pi, and because this thing is periodic, so I can write that as 2k pi, and therefore that implies me that z is equals to 32 cis to the power 1 over 5. And now we use De Moivre's theorem, and that tells us that this will be equal to 32 to the power 1 over 5 times cis pi plus 2k pi divided to 5. And it's 2k pi, I mean, k can have values like 0, but k can have values like 0, 1, 2, and so on. Coming back here, this becomes 2 cis pi plus 2k pi over 5. Now, depending on different values of k, we will have different roots. And as we talked, we can see that the power of this equation, highest power of this equation, is 5, so it will have 5 roots. And here also we'll need to use 5 different values of k. Any 5 consecutive values would do, and if you take more values, then the roots start repeating because they are periodic. So let's start with k equal to 0, and that root we will call z0. So k equals to 0 will give you first root, which is z0, which gives you 2 cis pi over 5. Then k equals to 1 will give you z1. I'll call that root as z1, and it becomes cis2 cis pi plus 2 over 5, or call it 2 cis 3 pi over 5. Let's go to the second column here. K equals to 2 will give me the root z2, which is equals to 2 cis k plus not k here, it will be pi plus 4 pi over 5, which becomes 2 cis 5 pi over 5, which basically becomes 2 cis pi, which is minus 2, because cis pi is equals to minus 1 here. So we got 0, 1, 2, then we got k equals to 3, and that's my root, which will give me z3 is equals to 2 cis pi plus 6 pi over 5, which gives me 2 7 pi over 5. Now we need to remember that this argument here, we got 7 pi over 5. Now the domain of argument is from minus pi to pi. So 7 pi over 5 is outer domain. I mean, if I want to write the argument, the domain of the argument which is theta, then I can write it like this. Theta is greater than minus pi and less than equal to pi. So this is basically has gone beyond pi. It's more than pi. So it's more than pi here. It's falling out of this domain. So we need to convert that into, we need to bring this into its domain. So what we can do is we can take minus 2 pi from this, which basically doesn't change anything other than the fact that it will be in the domain, and that will give you 2 cis 5 times minus 3 pi over 5, and the last root that we are getting is k equals to 4, and I call it z4 2 cis 5 plus 8 pi over 5, and that becomes 2 cis 9 pi over 5. Again, we need to, it's out of the domain, so we need to bring it to the domain. We can add or subtract 2 pi, but here we'll need to subtract 9 pi over 5 minus 2 pi, and that will give you my root as 2 cis minus pi over 5. So these are the 5 roots. Root number 1, root number 2, root number 3, root number 4, and root number 5. Let's move on to second part of the question. Label these roots clearly on an Argand diagram. So we see that all these roots that we have, they have a length of 2 here. You can see the modulus here is modulus, sorry, what is happening here? Okay. Okay, so we can see here that all of them have this, you got a 2 here, you got 2 here. So all these roots have a modulus of 2, which means that their length is, the length of all of them is 2. So we can mark them here. So on the Argand plane, you will have, all of them will have a length of 2, which basically is to say that they will all lie within a circle of radius 2. So I'll take radius 2 here, 1 2 1 2, and 1 2 here. That's I just draw a circle here so that I can draw all my roots with the proper length here. Okay, so going back there, first root is 2 cis pi over 5. 2 cis pi over 5. So cis pi over 5 makes an angle of real imaginary. I need to also say that that's radius equals to 2. To cis pi over 5, it means pi argument is pi over 5. So this root will make an angle of pi over 5, which is about 36 degrees with the real axis. So that will be my first root, and I'll call that C0. Then next one is 3 pi over 5, which is angle is 108 degrees. So 3 pi over 5 will be somewhere here. Then next one is 5 pi. That was 3 pi over 5. Next one is 5 pi over 5, which is basically next root is minus 2. So minus 2 is here. That's my third root. So this is my Z1, Z2, and Z3 after that is, if you look there, Z3, my third root is minus 3 pi over 5. So from here you went to plus 3 over 5, you landed here. If you go minus 3 over 5, 3 pi over 5, you will land here. So That's my z1, z2, this is z3, and z4 is minus pi 2 cis minus pi over 5. So this is plus pi over 5, minus pi over 5 will be here. We can see this root is 2 cis 3 pi over 5, and this is minus 3 pi over 5. So basically they are conjugate. This root is 2 cis pi over 5, and this root is minus pi over 5. So these are the conjugates. So we have a pair of two pairs of conjugate, this and this, and that and that. So z1 and z3 are conjugate, and z0 and z4 are conjugate. Just one mark, need to show these things, and we are done. Now we need to write as a product of linear factors. So we got 5 roots there, and obviously therefore we can write our pz as z to the 5. It's the same thing. If you make it an equation, you make it equal to 0, you get roots, and those roots basically form the factors of this polynomial. So the roots will be z minus 0, z minus z1, z minus z2, z minus z3, and z minus z4. And that's simple. That's all you do, and you just, it's not asking you to do anything. You can just write like, just put this value and you are done. That's my z0, z minus 2 cis z1 is 3 pi over 5. Third factor is z minus z2, which is equal to z minus 2, so it becomes plus 2. And z minus z3 is equals to z minus cis minus 3 pi over 5, and the last root is z minus, sorry, I missed a 2 here, z minus 2 cis minus pi over 5. And these are the 5 factors, and these 5 factors basically followed from 5 roots of the equation. Let's move on to next question here now. Next part, you got these 5 roots, well and good. Now it says considering two conjugate pairs form 2 quadratic factors of z5 plus z2. So we had 2 conjugates there. One conjugate of here, one pair of conjugate was z0 and z3, and let me, I think we'll need to go check and go back and check which is which. So z1 and g3, and z0 and z4. So we had conjugate z1 and z3. z1 was 2 cis 3 pi over 5, and z3 is 2 cis minus 3 pi over 5. And other pair of roots is, let's divide it into 2 columns so that we can work on them. z0 is equals to 2 cis pi over 5, and z4 is equals to 2 cis minus pi over 5. You see pi over 5 and minus pi over 5, basically that means they are conjugates. So here they are conjugate. So you got 2 factors there, you got 2 roots there. So these 2 roots combined, if you combine them, they will give rise to a quadratic factor in each case. So what we do is we find sum of roots and product of roots for both of them. So sum of roots is equals to z1 plus z3. You get 2 cis pi over 3 plus 2 cis minus 3 pi over 3, and here you can write them as conjugate, in Cartesian form. So we get 2 cos 3 pi over 5 plus iota sine 3 pi over 5, and this becomes 2 cos 3 pi over 5 minus iota 2 sine 3 pi over 5. They are conjugates, we can see that, because the imaginary parts have opposite sign. So we need to add them together. We can see that when we add these two roots together, we'll be only left with real parts here. So 2 cos 3 pi over 5, and this 2 and 2 becomes 4. You got 4 cos 3 pi over 5. Then product of roots is equals to z1 times z3. You don't need to write in Cartesian form now, you can straight away multiply them. So you got 2 cis 3 pi over 5 times 2 cis, which becomes 4 cis 3 pi over 5 minus 3 pi over 5, which becomes 4 cis 0, which becomes 4. So the quadratic factor corresponding to these is equals to z square. If you remember, then this you have sum of roots here. So we got minus sum of roots is, we got 4 cis 3 pi over 5, 4 not cis, cos 4 cos 3 pi over 5 z plus the product of roots plus 4. That is one quadratic factor that you got corresponding to these two roots here. Here also we can do the same thing. So I can write this as 2 cos pi over 4 plus iota times 2 sine pi over 5. And this becomes 2 cos pi over 5 minus iota 2 sine. Just like these two roots here, sum of roots is equals to, you add them together, the imaginary parts cancel out, and you're left with 2 this and 2 this. So you get 4 cos pi over 5. And likewise we got product of roots, which is equals to, if you multiply these in polar form, let's see, 2 cis pi over 5 times 2 cis minus pi over 5, that becomes cis pi over 5 minus pi over 5, which is equals to 4, because cis 0 is 1. So the quadratic factor here is z square minus sum of roots. Sum of roots is this, 4 cos pi over 5 z plus you got product of roots, which is equals to 4. So these are the two quadratic factors corresponding to two pairs of conjugates here. Next part is that we need to write that into one linear factor and one quadratic factor. So we saw in previous part that we got two quadratic factors and one linear factor. So if you look at that we go back and we can see that that's my linear factor, and I got two quadratic factors here. Z square minus 4 cos 3 pi over 5 plus 4, that's one quadratic factor. And other quadratic factor is minus 4 cos pi over 5 plus 4. So that is my linear factor, and these two together can give me a quadratic factor. So I just need to multiply them. It's a lot of grunt work here. Quadratic factor, so you need to multiply them together. I'm just going to multiply them on the fly. So z to the power 4, and then z to the power cube terms, we will get two of them, so 4 cos pi over 5 z cube minus 4 cos 3 pi over 5 z cube. Now we're looking for z square terms. So z square terms is you get when you multiply z square with this 4 and that z square with this 4 and multiply these two terms here, 4 cos this middle term and that middle term. Sorry, I missed a z here at both places. So you will have three terms correspond for z4, so z square. So first one is 4z square here plus 4z square here. These two, when you multiply the two middle terms, you get a 4 there, you get a z square there as well, so that becomes plus 16 cos pi over 5 cos 3 pi over 5 z square. And then we looking for z terms. So z term is you get one z term by multiplying this term here with the 4 here, and likewise this term here with the 4 here. That will give us a z in both the cases. So that z term, the two z terms will be 4 times 4, so minus 16 cos 3 pi over 5 z, and then you get minus 16 cos pi over 5 z, plus 16 is your final constant term. You can simplify, so you got z to the power 4 minus 4 cos pi over 5 cos 3 pi over 4 5 z cube, plus now here you get 8z square and z square, so and 16 there as well, so I'll take out 8z square common, and what I get there is because we got 8 here, so 8z square, so there will be 1 plus I get term 2 cos pi over 5 cos 3 pi over 5. That's your z square term, and then z term is again you got the 16 and 16, so you can take out 16 common and you're left with cos pi over 5 plus that plus 16. So this is your quadratic factor, and if you want to write that factorize into one linear and quadratic factor, so one linear factor is z minus 2 and this is our quadratic factor. You can, I mean, if question might not specifically ask you to write as product, but you could write that, or you could straight away say that that's your quadratic factor, and the linear factor is equals to z minus 2. So these are what you got there. Alright, and the last part that we have now is let's take a look. It's a longest kind of question, and this is the last part, which say that from B and E we need to talk about we need to show that cos pi over 5 plus cos 3 pi over 5 equals to half. So all we need to do is from just the previous part we had that z to the power 5 plus 32 is equals to, we can write that as a product of, oh, did I make a mistake there? Yes, the linear factor is not minus 2, it is z plus 2. We need to be careful with that. So z plus 2, and that quadratic factor that we just had in previous part, we'll need to write all that. So let's do that. Let's write that thing, and that's the linear factor, and the quadratic factor I'm going to write here, z4 minus 4 cos pi over 5 plus cos 3 pi over 4 5 z cube plus 8 we got cube term, then square term is, we got 8 times 1 plus, need to go back and check again, 1 plus 2 cos pi over 5 3 pi over 5 z square minus 16 cos pi over 5 plus cos 3 pi over 5 z plus 16. So this is our left hand side, and that I have represented as a product of right hand side. I have represented as a product of a linear factor and a quadratic factor. Quadratic factor is factor with the highest power of 4. Now I need to find where can I get this thing, this cos, where can I get that expression? That's what I need to see, and I see that I can get this thing from here. This term will give me a cos pi over 5 and cos 3 pi over 5, and that term will also give me cos pi over 5 and 3 pi over 5. So when I look here, this side I only got one term, which is z to the power 5. When two polynomials are equal, then just like your complex numbers, like when you have two complex numbers which are equal, then their real and imaginary parts have to be equal separately. See, in the similar way, if you got two polynomials which are equal, then the coefficient of each term has to be equal on both the sides. So we'll look at this term and we'll see this. We got a z term here, and we have a z term on this side with the coefficient of 0 here. So you'll find a z term from the right hand side, from the left hand side and the right hand side. So I can write like this, that let us equate the coefficient of z on both sides. Now on the left hand side, coefficient of z is equals to 0 because there is no z term here. On the right side, I'll get a z when I multiply this term with a 2 here and that z with this 16 here. Both of them will give me a z. So the first z term, I'll multiply this with the 2 here, so that becomes minus 32 cos pi over 5 plus cos 3 pi over 5. That's the one z term I get by multiplying this with this. Other z term is I get when I multiply this 16 with this z. So that will give me plus 16. Very simple. When you multiply these coefficients of z on both the sides, because these, let me again repeat, you got two polynomials which are equal, then coefficient of each term on both the sides have to be same. So coefficient of z to the power 5 will be equal to coefficient of z to the power 5 on the other side. And likewise, we equated the coefficient of z on both the sides, and from here we can straight away see that this will give us cos pi over 5 plus cos 3 pi over 5 is equals to minus 16 over minus 32, which is equals to half. And that's what we were required to prove, and we'll stop on that.